Yeah, so first of all, I want to invite everyone to join the Slack channel for this talk. I'll be keeping that open to see any questions. I probably won't follow the questions in Zoom or on YouTube. I'm not intending this to be the most perfectly scripted start to finish talk. So yeah, if you've got any questions, post them in Slack. I'll try and get to them. So yeah, thank you very much for joining me today. I'm going to talk to you about open source license compliance with Yocto project. So yeah, a little introduction about me. I've been involved in Yocto project since around 2013. I work across the whole embedded software stack, mostly sort of single board computers, helping out hardware vendors with their Yocto project support. I'm currently principal engineer at Consulco Group, providing those services to clients, and there's some contact information on this slide. So, got to start with a bit of a disclaimer since we're talking about license compliance. Nothing I say in this talk is legal advice. What I'm trying to give you is best practices based on my experience as a developer, my experience as a member of open source communities. And if in any doubts on any of this, consult an appropriate lawyer. So this talk, I'm going to give a bit of an introduction, talk to you about license compliance, Yocto project, the tools that we've got, provide a bit of a brief overview for those who may not be very familiar with these tools. Then I'm going to look at a couple of sort of newer topics for us, which is the language package managers that have come along with new programming languages. I'm going to talk about SPDX and the tools can be used to generate SPDX documents. I'm going to talk about finish up with future work that can go on in this area. And as I say, I'll be taking questions on Slack during and after the talk. I did a previous talk on license compliance, very similar subject at ELCE in 2019. There's video and slides available for that. That's a bit more of a deep dive on the basic tools that we've got in Yocto project. I'm not going to duplicate all of that content today, so if you're interested, I highly recommend watching that and having a look at the slides. So yeah, the best place to start really is why should you care about license compliance? Well, if you sell an embedded Linux device running embedded Linux, typically that's going to involve distribution of open source software that is physically present on the device. That carries a risk of legal action if you don't do it properly. So the right way to look at this is risk reduction. The other thing is doing this well gives you standing and positive reputation within the open source community that can really help when you then want to influence those communities and participate. And the third thing I always say is really you need to be keeping source code of all the third-party components that you use anyway to help with debugging, satisfy customer requests to rebuild something you did 6 months ago with one little patch. Sources do disappear from the internet, so you need to keep your own copies of this anyway. And once you've done that, you know, it's not too much of a leap from having all that source codes archived to being able to fulfill your license compliance needs. I also want to give a brief introduction to the Yocto project for anyone who isn't familiar with it. This is a toolkit for creating a fully customized embedded Linux distribution for your product. It's widely adopted. It's practically an industry standard at this stage, and we've got a really welcome and active community of developers. And yeah, there's several features that we've got that are specifically geared towards supporting license compliance. So really brief example of a Yocto project recipe. So recipe is the thing that contains the metadata and the build commands for a particular piece of software. So this is just a recipe for a Hello World application. It shows the license. This format here is an SPDX license identifier. I'll mention a little more about SPDX later. It's just a standardized way of identifying a license. And we also call out a license file and the checksum of that file within the source tree. This just helps us to automatically notice if that license changes when you upgrade the software. So this metadata is kind of the starting point for license compliance activity. The metadata in public layers isn't always perfect, but it's usually in a pretty decent state. So once you've got these recipes and you're building software and building images from the recipes, first step to license compliance really is being able to provide the sources for components which are under copyleft licenses. And the Yocto project supports you to do this. We've got an archiver class that will collect the source code for any recipes that are built, usually collect it in either sort of the original form as it would be distributed. Can also collect it with patches applied or after it's been configured. And this is all done by adding this line here to the local configuration file for your build, and then setting one of these archiver modes. The mirror archiver mode at the bottom is one that I worked on over the last year, which is really geared towards producing a full mirror of all open source software, which can then be reused in future Yocto project builds. The archiver can also be tweaked and configured further to support your use case. So we support filtering which software packages you want to include the sources of, along with several other variables which are covered in the project documentation. The kind of other half to license compliance is providing the actual license text and copyright notices. This is often a requirement for permissive open source licenses as well as copyleft licenses. We collect all that license text as part of the artifacts produced by a build anyway, so you can simply copy this directory, but it will probably need a bit of post-processing to make sure you've got just the licenses that are actually relevant to your current build. If you're distributing a product and you want to include the license text in the actual file system image that's going to go on the product, we also support that in two different ways really. One is by including this at the image generation time, and this just collects all the license text into one directory when the root file system image is created. The second is to create license packages for each software package, and this gives you an installable package and provides an upgrade path if you're doing sort of on-device upgrades using apt or yum or some other package manager. This provides you a way of getting the newer license text when you update a package. So a couple more tools that we have. We have the ability to exclude unwanted licenses from images. So if you're building something and for whatever reason you maybe don't want to include in GPL3 or later is kind of the go-to example that people use, but if there's a particular license which you want to make sure that no software covered by that license is included in your image, you can add that to this incompatible license variable within your build configuration. And that will then block the inclusion of packages which have that license. Typically, this applies to target packages only. That is, packages that are built for your embedded device that are going to go into the root file system. So this doesn't prevent things like a cross compiler or a development tool that's only used on your build host from being used. If you do exclude GPL3 licensed components, you may need to use the Meta GPL v2 layer to pick up older versions of some software packages. If that is the direction you go in, I highly recommend you contribute to the GPL v2 layer as well, because that really does rely on the people who are actually needing it and using it, helping to maintain it. And kind of to support this, what we do in all the core layers within Yocto projects and what we recommend in all other layers is use the standardized license names from the SPDX license list to identify licenses. That avoids confusion, and it ensures that, you know, when you add something like GPL-3.0 to your incompatible license list, then that is the word that's used in the license variable for every recipe as well. The other thing that we've got is license flags. Sometimes this gets a little confused. What's license flags? License flags is a way of identifying recipes that have some additional terms beyond an open source software license. So this may be a commercial license or an end user license agreement that you have to agree to. It may be that the software uses patented algorithms, which may or may not be an issue for you depending on your use case, your jurisdiction, and other questions. So when license flags are set in a recipe, that results in the recipe being excluded from a build by default. And you need to come in and add those recipes to the license flags whitelist variable to enable those recipes. So this, in terms of open source components, you could see this for video and audio codecs. And it's useful for, say, flagging commercially licensed items as well. So one of the things we support within Yocto project is generation of a software development kit. And this is a self-contained build tool that you can give to application developers to let them build their code without needing to understand all the details of writing and maintaining Yocto project recipes. We've got two forms of the software development kit. We've got the plain SDK, and we've got an extensible SDK, which is kind of package based and allows you to upgrade the SDK on your developers' machines. The archiver that I mentioned before, that should capture the sources for any components that go into the SDK. So if you're distributing the SDK, you know, you want to treat that the same way you treat a routerfast that you're distributing and capture those sources. For the extensible SDK, things are a little bit different. I would highly recommend you do some research of your own there, because of the way the extensible SDK is built, there maybe is the opportunity for the archiver to miss things and some additional work required there. If your developers use the SDK to build software outside of Yocto project, that obviously bypasses all of our license compliance tooling. So do be careful distributing code that is built in that way. Just to jump back a little bit, where was the thing on GPL v2 layer? So Alexandre asked, do we know how well Meta GPL v2 is maintained regarding security fixes? I think I'm not sure off the top of my head. I imagine it's pretty much parked where the last GPL v2 release of a component was made, and if you need security fixes for that, that is a place where we would recommend you get involved and help us out with those things. So next topic I wanted to cover was license package managers. So this is something that's become a little more of an issue in recent years. So many newer programming languages use their own package managers. I mean, maybe not just newer ones. Python's always had its own language package manager. But for languages like Go, has the Go build tool. JavaScript, Node.js has the NPM Node package manager, and Rust has the Cargo build system and package manager. And these do present some issues for embedded development and for license compliance. You know, the concerns of embedded developers and the concerns of achieving license compliance just don't seem to be the things at the forefront of the developers' minds, the developers of these tools. And some of the features that I would say we need do seem to be missing from these tools. So the features we need to achieve this, from my point of view, is offline build support. It's very difficult to ensure that you've got an archive copy of all the sources you need and you've collected all the license text and everything else if the build process actually goes and interacts with online components and downloads additional components during the compile stage. We really need to be able to support offline builds as a baseline here. We need an automated way of downloading source archives for not just the package itself, but for all the dependencies. And that needs to include license text. It needs to include various collateral files, sort of readmes, installation instructions, and everything else within that source archive. We need to be able to support HTTP, HTTPS proxies. This maybe isn't a license compliance issue, but it's definitely an embedded cross-development thing to support people who are behind either corporate firewalls or national firewalls and may not have access to all the online services that some of us take for granted. The tools also should support source mirrors. So they should not be insistent on always fetching directly from a particular upstream canonical package manager website. You need to be able to provide your own mirror of those components. And that's important for testability. So to test that you've actually achieved license compliance and you've actually got all the source code, you want to rebuild just from your local mirror of that source code and see that it does actually work. And that will then show you that you've got a complete source archive for your image. So those are the features that you really need to look for when dealing with one of these language specific package managers. I want to sort of dive into one of these languages in particular, which is Rust. Rust is a language that came out of Mozilla research a few years back and has been growing in popularity in pretty much every area, including embedded software development. And it provides a lot of unique benefits and unique guarantees. So the Rust software written in Rust is built using a tool called Cargo. And Cargo is built both a build system and a language package manager for Rust. And so a Rust project typically includes a configuration file for the Cargo build tool. And This includes metadata, such as a description of the software, the authors, the license, the other things you'd normally find in a Yocto project recipe as well to identify and describe your software. It includes a list of dependencies that are required in order to build an application or a library, and it includes configuration options for your piece of software. It could also include the configurations to set when building dependencies. And the cargo build system is also associated with a software registry called crates.io. And this is a place where open source projects written in Rust can publish their source code. It provides search, it provides download functionality. So let's dive into Rust with Yocto project. Rust support is done by the Meta Rust layer right now. We're having a few discussions about bringing that into the Yocto project core, but right now it's in this Meta Rust layer. Because there's so much information in that cargo configuration file, we can generate recipes automatically using this cargo-bitbake tool. And it seems to do a pretty good job of things. It includes source URI entries for all the dependencies of your project. It includes a fetcher that allows bitbake to go and fetch these dependencies, typically from crates.io. And it includes a cargo class that describes how to build Rust projects. And this supports offline builds. It uses this bitbake fetcher to download all the crates you're depending on and does the build offline, which, as I say, is one of the key features we need. And this works pretty well with most of the Yocto project tooling that I've described. The archiver that I mentioned before supports HTTP proxies, it supports source mirrors. That all works pretty well. The one thing that is missing is those crate dependencies. The cargo bitbake tool doesn't actually go and find the licenses that apply to all those dependencies and collect all the license text for those. So there's an additional step that we either need to add into the cargo bitbake tool or that you need to be willing to do yourself when using software written in Rust. The next thing that I want to cover quickly is SPDX, which I have mentioned already. An SPDX describes itself as an open standard for communicating software bill of material information, including components and licenses, copyrights, security references. SPDX is supported in Yocto project by the Meta SPDX scanner layer. This layer provides tools to scan source code, to identify licenses, and to produce SPDX documents. That is essentially a software bill of material with all those licenses and copyright information in that document. The one thing I will say is generation of SPDX documents is typically a slow process because it involves scanning all the text files of your software to look for the licenses involved. It can extend build times by several hours. This is usable on a release build. When you do a release, it's not really usable on day-to-day development builds. But one thing we do support is scan code. So scan code toolkit does this job of looking through all your source files, identifying blocks that look like license text, and pulling out those license names into a big long list. So that is included as a class within Meta SPDX scanner layer. You can either enable it globally by adding that to local.conf, or you can just say inherit that class in the specific recipes where you want to do that license scanning, because obviously license scanning something as big as the kernel is going to be very, very time consuming, and you might not feel that you need to do that. Another component we can integrate with is Fossology, which is a much more fully featured system for license compliance scanning and for manual sign-off processes to confirm that you're happy with the results of the scan. Runs as a service with a web interface and an API. The SPDX scanner layer provides integration with this as well. I'm going to skip over this as I'm running out of time. And I'm going to wrap up with some future work. What I would like to see is better integration with those language package managers, which may require some extra features in the package managers themselves. I'd like to see automatic generation of a more user-friendly plain text or HTML license document for an image. There are other license compliance tools like the OSS review toolkit that we can integrate with. And I'd like to see some of these license scan and SPDX document generations tools used for our actual Yocto project releases, though that is non-trivial. And just a final link slide with some additional links that I've added after I published these slides online. So I've got a link to my Twitter and personal website and blog. Carlo's talk this morning was excellent. I highly recommend giving that a watch if you're interested in license compliance. He mentioned reuse.software, which is very interesting on this front. Within Yocto project, we've got a licensing mailing list if you want to discuss any of these topics. And if you're interested in licensing, I highly recommend looking at the Open Chain project. So thank you very much for that. I will be around on Slack to discuss further or answer any questions.